for joining us today for this webinar, Skydio in the Classroom. Purdue professor speaks on drones and autonomous drones in higher ed. My name is CJ Smith. I'm with the Adorama and Adorama Drones team. Adorama Drones, one-stop shop for universities and educational institutions looking to get exposure to drone technology. Really looking forward to this discussion today. We have about an hour and we'll be reserving the last 15 or 20 minutes for Q&A. So you should see a little Q&A or chat button on your screens, on your Zoom screens. Please drop those questions in the chat throughout the day, throughout the hour, and we'll make sure to get to them all at the end. Again, this webinar is being recorded, so we'll make sure to email out the recording to all attendees after the session, and you can watch it again or share it with any of your colleagues. So quick agenda for the day. We're going to give some brief introductions in a second to the presenters, as well as to Adorama Drones and Skydio. And then we'll dive into a bunch of student work examples. We'll talk to Professor Huppy. He's going to walk us through kind of his approach, some of his motivations, and also his experiences when it comes to incorporating drones into higher ed curriculums. So with you today, like I mentioned, my name is CJ Smith, representing Adorama Drones. Joined today with Professor Joe Huppy from Purdue University, as well as Angad Singh, Channel Sales Manager with Skydio. And I'll let them introduce themselves a little bit further in just a second. So you may ask yourself, who is Adorama Drones? So Adorama as an organization has been around for about 40 years, originally starting in photography, videography, and the drone team here is focused on helping government, educational institutions, as well as private companies incorporate drones and drone technology into their processes. So from training to professional consulting, hardware, software, financing, buyback programs, we work hard to kind of build out a full one-stop shop and drone ecosystem to help the customers and government agencies, organizations take advantage of this technology. So without further ado, I'm going to pass the mic off to Angad Singh, Professor Huppy, to briefly introduce themselves and talk a little bit more about Skydio drones and why these drones are used in higher ed today.
Cool. Thanks, CJ. Hey, my name is Angad Singh, and I'm a channel sales manager at Skydio. Basically, that means I manage, companies like Adorama that sells Skydio technology to end users. Adorama has a really amazing team for higher education, and they service a lot of universities and high schools that are buying drones out there, and they've been a really good partner for us in the educational space. Skydio is an American company. If you haven't heard of Skydio, it is the largest American drone company today. And when we're thinking drones, we're thinking, small quadcopters, smaller drones, not really big drones. So we're thinking things that can be put into a backpack that are more personal level, that carry a camera around. And these are amazing flying cameras, and they're autonomous flying cameras. Skydio is an AI company. I think colloquially, I like to think of Skydio as like a flying Tesla. So when you sit in a Tesla car, you see all these camera systems on the vehicle, see everything in the world around it, and it allows the vehicle to make decisions that keep those people in the vehicle safer than if they were in a car that didn't have those levels, autonomous system capabilities. Skydio drones operate very much the same way. They're fundamentally different than a lot of the other drones on the market because they're based off AI. And we'll talk more about how this navigation-based camera systems on the drone allow them to be different and allow them to be unique, and also allow them to be really cool and do stuff that other drones can't in the market later. I think something else that's important about Skydio is, yes, it's an American company. It's a Bay Area tech company. We have, close to 600 employees. We have a lot of folks that come from really cool companies and also come from really cool universities. A lot of our flight test team, they come from, Embry-Riddle programs. A lot of our autonomy engineers come from MIT or Caltech or Berkeley. I studied drones in university, and that's the only reason that I'm here today. And I think that got my jump start. So I have a lot of respect for the EDU space, and I want drones and drone programs to be in universities and high schools and even at the middle school level. I think that's really cool. I think that the last thing here is that we are trusted in terms of a company. It's an American company. The drones are manufactured in the United States, and we'll talk more about that in a moment. But Skydio as a tech company has also been making waves because it's getting a lot of awards for being different, but also having really innovative technology. And we've also shipped over 35,000 units into the world. And that's important to know because you're not just dealing with a tiny little, startup that's getting started, but you're dealing with a company that's really in a massive growth stage. And this is the drone of choice for a lot of the branches of the US military, major utility companies, and a lot of universities are starting to adopt Skydio for their drone programs. And I'll pass it over to Professor Hupy from Purdue.
Thanks, Angad. So yeah, I'm Joe Hupy, and I'm here at Purdue in aviation program. So I'm in the School of Aviation, but it's kind of strange because I'm in an aviation program, but with a background in soil geomorphology. I still continue to engage in a lot of different forms of research in the natural resources realm, in the forestry realm, and with soils. I got into UAS out of necessity, and it's kind of fitting given what we have going on in Ukraine right now. But what I researched was how battlefields recover from explosive munitions. So I coined the term bomb turbation. When I was originally doing this work, it was on the Western front of France. I did follow up with some work years later with drones, but at the time, my methods were very much just using measuring tapes and some GPS. In Vietnam, I was doing some work in the Central Highlands, and there were so many unexploded shells and leeches and whatnot that I was wanting to not do ground-based research. And so I was tinkering with using balloons and kites on how to do my mapping. And so it's kind of interesting because OnGod comes from Pix4D, and I remember when Pix4D was a very small booth at the Esri conference, and they were specializing in just overlaying old photographs. And that's how I was talking to them, because I was looking at how I might be able to use this with my balloons and kite technology, and also looking at some old World War I battlefield imagery. But because I was involved in that, right around the times that drones started to get really big, I was approached by some people. I did a mapping of the China Lake Naval Weapons Range. I then got into a lot of work with mines in terms of doing volumetrics with the mines. And then I also started working with them related to disturbance in terms of how that you can use drone technology in the imagery to look at how the vegetation recovers in terms of restoring the overburden. This led to Purdue more or less kind of recruiting me, and me coming from Wisconsin to Purdue in 2018. At the time, the UAS curriculum at Purdue was focused mainly on kind of RC and building platforms. And what I said is we really need to focus on the sensor technology. And so that philosophy I brought forward to Purdue was training UAS how to utilize UAS as a geospatial data collection tool. So not only the aviation component, the safety component, but mission planning, data collection, data processing, data analysis. And so that's my big philosophy, is an end-to-end approach. All my students come out and they understand this from start to finish. And I tell a lot of them, hey, you don't have to do, there's a good chance that you won't be doing the GIS, but when that person is in the GIS lab or doing this data processing, or you have a client that wants that, you'll at least understand where they're coming from. So right now I teach 4 courses that relate to UAS. The AT309 is a mid-level course where they mainly learn about the different sensors in terms of different forms of resolution: bit depth resolution, spatial resolution, temporal resolution in some ways in terms of the flight, but then also things like radiometric resolution. So they learn about thermal sensors, multiband sensors, high resolution RGB sensors, and they also learn quite a bit about basic geography in terms of coordinate systems and projections, as that's very, very important. And a lot of the problems that you see in the drone world relate to that. And then UAS applications, they start taking data that they go out and collect, and they start putting into a geographic information system and doing some analysis. And then the senior capstone, the idea behind that is for them to take what they learned and then apply it to something that is of interest to them. I'm also teaching a graduate course right now, GIS and Aviation, that relates to UAS, but it doesn't necessarily involve the imagery. A lot of what I'm doing in there deals with air traffic management. And so with that, I'll put myself back on mute and I'll turn it back over to CJ.
So I think I'll take this, CJ, I take this one, right? So here we're talking about drones, or sorry, Professor, we're talking about drones, and we're talking about how that progression has happened, right? So how did I get to drones? I get to drones because I was in a remote sensing class, maybe similar to the one that Professor Hupy teaches. And I then, worked with my professor at McGill University to do a research project, and we were analyzing satellite data. And with satellite data, you get X of amount of resolution. Now, with the drone, you're significantly closer to the ground. You can collect data when you want to collect data. You don't have to worry about a cloud, maybe on top of an area that you wanted data of at a particular time, so it wasn't available. So there was an increase of that temporal resolution. Then there was also the ability to access places that you couldn't get with an airplane or with a, with a satellite. For example, as this picture here is on the right showing, underneath a bridge. And then as the drone technologies evolved, we've also enabled where we can go with drones to significantly increase as well. Here, we're able to take photos and turn those photos into 3D maps and models, or we're able to take photos for inspection applications. And so now UAS has become this niche data collection tool. With Skydio augmenting the drones that are, older drones are primarily GPS based, Skydio drones are navigation based. Now the drone is seeing everything around it, and it's able to do stuff that other drones can't. And so what are some of the advantages of AI-based navigation with Skydio drones? Well, they're the easiest drones to fly in the world. They're the hardest drones to crash. You can fly at full speed at a wall, and 3 feet from that wall, it will stop because the cameras on board are seeing where it's going. So that, let's say that you wanted to do a project, showing students what a bridge inspector would do. Well, you can fly underneath a bridge and fly, as fast as you want, or well, not as fast as you want, but kind of carefully and methodically towards a particular beam where there may be a crack or you need to inspect it. And now you can be sure that those students are going to crash that drone, just as the inspector in the real world who's doing, or, in the industrial world that's using that tool is also able to do the same task. And so we're taking that same level of technology that industry is using, bringing it into the education space and showing them those industrial applications. And with Skydio AI-based navigation, you're implementing a tool that's really easy to use and safe to use. I guess, Professor Hupy, where have you seen those lessons of Skydio technology versus other technology as the UAV space has evolved in your classroom?
Oh, indeed. If we go back to the early days, a successful day was not crashing and having the platform take off. I guess one of the more poignant stories in this is I remember once I was in Vienna, Austria. I was speaking to a group on the impact of on bomb turbation, and this was one of the geomorphologists was talking about how they had a drone, and then one of the ladies said, "Oh, he doesn't have it anymore." And I said, "What happened?" And she said, "We put it up in the air, and then it disappeared and went off into the mountains. We went bye-bye." And so that was one of those things to where it probably had a previous return to home type function, and that happened. I've seen these things when you didn't have what Skydio has in terms of not just relying on GPS, but also relying on that AI in terms of the vision. I've seen GPS signals go awry, and because of what's called multipath air in GPS, I've seen drones smash into the side of buildings, into the side of aluminum boats. I've been in situations in consulting where I had to use GIS to make sure that we didn't fly into a radio tower in Honduras because we had to launch off of a gold leach pad that was soaked in cyanide, and that was kind of an interesting situation. So the technology has gone so far, but with Skydio, one of the things I'll say is that I remember when my students were first flying these, and they were indoors, but not only just indoors, outside, and they were imaging a sign. And I remember just tensing up every time seeing these drones fly close to a tree or fly close to this sign, but then they would just stop and just go around. It's incredible how far we've come from those early Wild West days.
Yeah, I totally agree. And I think, by the way, those Wild West days, for those in the audience who don't know, we're talking about 10 years ago, maybe even 5 years ago. I think the drone industry has transformed significantly over the last 10 years. And within the last 2 to 3 years has even taken significant leaps forwards, right? I mean, Skydio as a company has really emerged in the last 3 years as a major player and the leading American player in this space. And that's how, when you're, from my perspective, is see what Professor Huppie's saying, you're implementing a drone program in an educational institution. Well, we have to make sure the equipment that's being used is also safe for the students and the people around, and the assets that you may be flying around. And that's really important. We also, in preparation for this webinar, we also wanted to bring up some regulation considerations for those that you're not just thinking about what type of technology you're implementing into the classroom. And then later on in the webinar, we'll tell you what the curriculum looks like that Professor Huppie is talking about, is teaching. But we also want to bring up some of the considerations around regulation that educators and program managers should think about when they're bringing UAS into the classroom. And I think the first thing to consider is the small coverage area, right? Yes, drones can theoretically fly 1,000 feet in the air and really, really far away. But in an educational space, you want to be safe and you want to follow the rules. So you want to fly within what we call visual line of sight, where you can see where that drone is. And you also want to make sure that you're never flying more than 400 feet above the where you're at, because that's airspace that you're not supposed to be in. And all of these rules are what's under considerations from the FAA with a remote pilot's certificate called the Part 107 exam. And I think that, I'll let Professor Huppie talk more about how those impact them in the classroom and how that also is taught to the students.
Yeah, I mean, this is a big deal. One of the reasons why I was excited to be in an aviation program is that, for one, you're dealing with a group of people who are not going to be going rogue, but for the other component of it is that a lot of these regulations and these restrictions can be pursued with waivers. And being in an aviation program, we have the ability to pursue waivers. And so, one of the things that I always say to students is that one of the most valuable people in a UAS company are the people that understand the regulations inside and out, so they can pursue these waivers. And at Purdue, with all the different collaboration that I do, ranging from people in earth sciences to wildlife scientists to foresters and whatnot, one of the biggest questions that I often get is when they want to map out a large area, and I say, well, we're going to have to do that in multiple flights. And they say, well, what kind of platform can we get to do that? And I have to say, it's not the technology. I mean, I have a fixed wing aircraft that we could do that can be up in the air over 2 hours. We could do a massive area if we are able to fly at a high enough altitude. It's not the technology, it's the restrictions. And fortunately, as we move ahead, what we see is UAS getting integrated more and more into the airspace. And with a bias in terms of GIS technology, is that the more we move forward, the more we're going to see GIS as a component of UTM, not the coordinate system, unmanned traffic management.
Yeah, and I think one plug as well here is don't be scared off by the regulation, right? This industry has been going for close to 10 years. Educational institutions should absolutely be bringing drone programs in. And, folks at Adorama Drones or, Skydio even has regulatory services that you can purchase as consulting, where they will help set up those waivers and they will help set up the program for the institution to make sure that you're following all those rules, to make sure that you're educated on what the rules are, but also to make sure that you're successful. And I think that we're at a standpoint in the industry where, yeah, regulation is really important, but you should absolutely never be scared off by it. You should just learn it, embrace it, and use it to your advantage. And I think that was an important discussion that we just had right there.
Yeah, if I can just jump in on that, just as a little follow-up on that too, on God, is that one thing about small coverage area when you're teaching, whether it's the middle school level or high school level, is that when you're doing this from start to finish, people want to cover that massive amount of area and they want to get, the highest resolution. They want the 64 megapixel camera, but all that excitement goes away when you're staring at a computer, waiting and waiting and waiting for even 100 drone images to process into a point cloud. So small is good in the teaching
Yeah.
world.
In the teaching world. Yeah, absolutely. I think that is important. So I think here we want to talk about some of the considerations of the technology, right? Because you're bringing in UAS into the classroom, but you're bringing in an interdisciplinary technology, right? It's not just about the drone itself. It's about what is the tech that evolves itself into the drone technology, and then what are you using it for? For example, in Professor Yuppie's use case, they're out there doing geoformology. They're using drones to study land. So it's not only about the science of the land, but it's also the science of the drone itself. And in a lot of my remote sensing research in university, I combined AI-based analysis techniques by flying drones over farm fields to build crop yield prediction models. So I was looking at agriculture, I was looking at crops, and I was also bringing drone technology into that sphere as a flying camera sensor. If we look at drones themselves, drones were kind of born out of the cell phone agency world, right? Because as cell phones got more advanced, the IMUs and the GPSs and the camera systems that go onto cell phones became cheaper and more prolific and more available. And then drone companies were able to take that technology, bring it into drones as well as the chips get smaller, and then create these very small flying aviation-based assets. And so, Professor Huppie, in your classroom, how do you bring all this technology together, and what are kind of the different ways that you're able to teach students about all of the different stuff that's out there?
Yeah, I mean, one of the things that I do in the classroom is I have them read several chapters from a book called The Digital Transformation. And it's that and The Innovator's Dilemma are two books that anyone, I would say, entering the drone space or in the tech world should definitely look at. But in the digital transformation in that book, what they talk about are these four components of the digital economy. And just to what Angan was saying is that all of these forms of technology more or less drove the drone revolution forward. Exactly what Angan was saying, with GPS getting smaller and cheaper, IMUs getting smaller and cheaper, the internet technology, the ability to store this imagery, AWS. But now what we're seeing is drones driving these four components forward. And so one of the things that I do in the classroom is that I constantly bring up these four forms of technology in the students when they have their write-ups. And when we discuss a given form of technology, when we discuss the Skydio platform in Skydio training, one of the ideas that I have in terms of critical thought is that I'm constantly saying and calling on students and saying, okay, how can we relate to this form of technology on these Skydio platforms in terms of the four components of the digital transformation? And when we start looking at that and they can start applying that, what we also say is, how can we drive this digital transformation forward with drone technology as well? And so we talk about what's needed in terms of integrating drones into the airspace, what's needed in terms of integrating drones in agriculture and forestry studies, in terms of those IoT solutions of sensors, ground-based sensor networks such as soil moisture sensors. So all of these different things we're just throughout not just one class, throughout the curriculum, we're constantly discussing and writing about these four components, because this is the digital transformation and drones are no longer being driven by this. They are driving this as well.
Absolutely. So here we wanted to jump into what you've been seeing in some of the graphics that have been on the other slides, and how Skydio-based technology is teaching autonomy in the classroom and using autonomy to make the drone itself safer. So traditional drones in the market, they rely on a GPS and an IMU to stay stable. So the drone connects to multiple satellites, and then it has position hold in the air somewhere, right? This also means that if you go into a GPS denied environment, such as inside a building, under a bridge, inside a warehouse, that loss of GPS signal can affect the performance of the aircraft. It also means that the IMU and the magnetometer on board that are essentially keeping that drone upright in the air they can also get confused from oncoming signal from electromagnetic interference. For example, if you're flying right next to a utility pole, there's electromagnetic interference coming out that can confuse the drone and have it crash. If you're on a college, campus, or even if you're out in, near a farm field, there's utility poles that are next to that. That EMI can be a threat to the drone. Skydio-based autonomy is immune to EMI, and because it's based on navigation sensors, it can fly in GPS-denied environments, and it can fly indoors. And in the next couple slides, we're going to show some of Professor Hupy's examples from the classroom and how he's using this technology in safer ways to teach, industrial and real-world examples. So what does Skydio technology do? It's got 6 cameras on board, 3 on the top, 3 on the bottom. Every single one of those cameras imports video, and that video, it's seeing the world, right? It's seeing the world, and then on board, it's understanding that world. What do we mean? It's building a point cloud on board on the drone of everything around it, and it's recognizing what's closer, what's farther away. As you get closer to a tree, it will turn that tree into a blob of pixels, and it recognizes that that's an obstacle that maybe it shouldn't hit. As it's going towards the utility pole, it'll recognize those wires as long as they're more than ½ inch, right? There's, of course, a limitation to it. You got to have ½ inch and more. And it'll recognize those objects, and that drone, as it's flying towards that scene, will avoid it. What will it also avoid? Stationary people. This is important because if you're with a bunch of guys, students out there, sometimes students need to make sure that they have a piece of equipment that's safe as well. With Skydio drone technology, it's seeing, it's understanding, and it's acting based on that. Now, when we talk about acting, let's also expand that not just to the safety of the drone, but also some unique things that these drone technology has the ability to do. For example, Skydio drone technology has a software application called 3D Scan. What this does is you can show it a bridge or a unique structure, and it'll fly around that whole object, and it will capture photos. And then those photos can be brought into a photogrammetry software to make a point cloud or a 3D model. And that's a workflow that happens with bridge inspectors and architects and engineers out there in the real world every day. So Skydio-based autonomy gives you a really easy product to use, but also a drone that's safer and can do cool stuff. And CJ, if we want to go to the next slide, we just wanted to show the 2 specific types of hardware that Skydio technology has. Professor Hupy's mostly flying Skydio S2 Pluses. This is think of S as simple. The S2 Plus is a more simple drone. And on the right side of the screen, we have the X2. That's more of an expert level or an enterprise drone. The X2 drone is what a lot of public safety agencies, large utility customers, State Department of Transportations, and also most major branches of the US military are using to fly as a small quadcopter of choice. The S2 Plus is an amazing product. It's smaller. They both fundamentally operate the same way. They have the same autonomy, the same camera arrays, and they're really great pieces of technology. And so let's go on to the next slide so we can talk about more of how they're actually being used, right? Than just the sales pitch of the drone.
And I just want to note too, one of the big changes is the thermal camera, which comes on the X2. So if you do need to use thermal imaging, this would be a drone that would be more applicable for you.
Yeah, it's really cool. In some animal science programs, they're using thermal cameras on drones to count cattle in a field and in a ranch, and also to see maybe with the temperature changes in there. Here, we're bringing up a topic about American innovation and craftsmanship. The drone industry has primarily been dominated by non-American brands, but with the proliferation of Skydio and the advantages of the technology, we moved away from, we're moving towards this inflection point where more of the American technology is starting to dominate in the market. There's something called NDAA, National Defense Authorization Act. And the reason that we felt that this was important is, for example, I have a very good friend who's doing a PhD in marine sciences on the North Carolina coast. And there's a marine base very close to there. You're not technically supposed to operate non-NDAA compliant aircraft near or on that land. So for his PhD research technology, where they're flying over basically like to count oyster populations and to make sure that the conservation of the oyster population is done in an interesting, to do that environmental research, they're required to use NDAA compliant aircraft. And so they use companies that make NDAA compliant aircraft. So that's one example of the education world having to take this to note. And so now I'll turn it over to Professor Hupy to talk more about why this is an important concept for him in his classroom.
Yeah, no, that's really fitting on God. And I guess one of the things I'll say is that one of the reasons why in our aviation program we started looking into Skydio was because of what was going on with, I mean, it's predominantly DJI, but there was just an article that I read about how there's laws looking to bring what they're labeling as a Trojan horse out of all levels of government. But just as an example of just a few areas where this hits home is that I remember when this was banned from all critical infrastructure, this had a huge impact within the Department of Interior in terms of wildfire fighting. I've seen this to where there's a company that was taking the brains out of DJI and putting in these platforms so they could do inspections of things like utility stations. And really what really hit close to home for me recently was that I was approached by someone in wildlife sciences who's doing a deer count survey, and they were saying, you know, it's a DNR grant, and so they have to get something that's US manufactured. And right away I pointed them the Skydio and the X2. And in fact, I'm going to be doing some training with them here in the upcoming months for them to be able to use the Skydio X2 in a DNR grant for deer, coyote, and I think turkey counts as well. So this is just another example of why, you know, again, more and more what we're seeing is that is the need for these US manufactured platforms, but to another point, for these universities to not have to deal with overseas shipments and not have to deal with overseas troubleshooting and support. It's all here in US based.
And we were just talking, I think, just before we started recording that, you know, students that they are using an American-made drone in the classroom, there's a great chance they could get a job at that drone company. You know, companies like Skydio are growing and hiring, and you know, that's a great career path moving forward. So, and I think, yeah. So, Professor, now we're going to get into some of the examples from your courses. So. Why don't you take us through this first project, and I'll pull the video up in just a second.
Yeah, so again, you know, getting into my philosophy with teaching not just drones, but just in general. So when I was in Wisconsin, I taught field methods, and at the time drones were a part of the field methods class where the students were engaged in creating topo surveys with survey stations. They were engaged in navigation methods using compass and map that sometimes led to some interesting moments in the wilderness. But it's always hands-on, and it's always create the data and process the data. And so in Skydio training, yes, we sit in the classroom, and yes, there's a classroom component to the training, but rather than just telling the students, hey, go out and just do this flight, what I like to do is I like the students to, especially with this generation, you know, they want to be part of a cause, they want to be involved in something. And so in this case, what I have the students engage in is, this is my daughter's volleyball club, and it's a volleyball facility. And I contacted them and I say, hey, would you be interested in getting some promotional material for your volleyball club where my students will fly it? And they said, yes, indeed. And so what we did is we learned the different cinematic functions on the Skydio platform. This is outside of the 3D scan. And what the students were told is use your creativity and come up with some promotional type videos. And this is one where the students started out outside with the sign. And not only are they promoting the Boiler Juniors facility here for volleyball, but they're also promoting the abilities of the Skydio camera, because keep in mind, they're flying indoors. This is a waypoint flight mission to where they basically went through and flew and then set a series of waypoints. But what they're demonstrating here is the ability for this to fly indoors without GPS. And it's a little choppy here in the web, but what this is doing right here is they're weaving between these poles, and they get a shot of the American flag, they go underneath the flag, and then they go close to the hard deck and zoom along inside this facility. And they're really demonstrating the ability of this platform to fly indoors and to have that obstacle avoidance and to show the different types of video that you can have. This was really well received by this volleyball facility. They put this on their social media platforms. They're very excited. This is just one of many videos. Every group of students in this facility had to create some type of a promo video. And again, what they had to do was they had to make a series of videos, and each video promoting one of the many different types of cinematic functions that the Skydio platform had. And so they had to do a flyaway. And some of these they didn't do inside. I mean, some of these you wouldn't want to do inside, but they did, they submitted as an assignment each one of these. And then what happened again was that this volleyball facility was able to utilize this in their marketing. And this is not just limited to this volleyball facility. What I try to do is I try to be in contact with a variety of different people. Some of the volleyball parents are farmers. There's another woman who owns an outdoor beach facility in Indianapolis, iBeach, and she's really interested in getting some promotional materials for her new location. And so this is going to be an idea here, is that the students are going to be able to go there. There's no pressure, because as someone who did a lot of consulting, when you have the pressure of money on the line, that's where it gets dicey. But in this case, it's told, okay, these are students, this is training, this is and as long as these people aren't paying for it and everything, they're really happy about it. And again, I've done this with farms, I've done this with landscaping facilities, I've done this with, I will be doing this with this iBeach facility. So what I always like to do is apply it. Don't just have it where they just go out and say, okay, do these things and then just turn this in. Have it applied, have them feel like they're contributing to something. Plus it gives them great practice for entering the marketplace and understanding all of the different factors that go into a successful data collection, or in this case, cinematic activity. Okay, so in this slide, what you're looking at here is you're looking at what is called an EPortfolio. And one of the things that was really exciting between Angad and I when we were having discussions, you know, just this webinar was kind of nebulous, and we were just kind of talking about some of the different stuff we could do. And I brought up these EPortfolios and I showed him some, and you know, Angad got pretty excited, CJ got pretty excited over these. And what this is this is an extension of what I've been doing now since going back to 2013, when we had an entire geospatial major. And one of the reasons why I started this was because of the fact that when I graduated, I didn't have a portfolio. But then in exit interviews with students, one of the things that they kept on saying to me was that, you know, what should we teaching more of? And they were saying, you know, the GIS stuff is good, all that technology, but we keep on getting asked for examples of our work. And so what we did in Wisconsin is we started doing this within our geospatial major. I carried this over here to Purdue. And so right away in their first class, what the students do is they start posting all of the different skill sets that they've learned. And so in this case, this is Matt Schneider. He has a fairly decent ePortfolio. But what this ePortfolio allows them to do is it allows them to leave the university and not have everything stacked in papers on my desk or locked up in some type of an LMS like Blackboard or Brightspace. This is to where they have the ability to show the world what they're doing. And, you know, for someone like Angad, who used Pix4D as a student in his university environment, he learned a lot about Pix4D, but there are a lot of different students out there who are going to write on their resume, I know Pix4D. Even if they said, I know how to do this in Pix4D, when they can say, hey, I know how to use Pix4D, and here's a link to a point cloud that I made. I've put ground control points into Pix4D. I've entered post-processing kinematic data into Pix4D, and here's examples of that work. Here's workflows, here's how to, here are the final data products. And so this is something that they start within the 309 course, and they do this in their 319, and then they do this in their capstone. So that's 2 years. I just found out from another faculty member in the UAS program, Nathan Rose, that he's now doing this in his 200 levels. So now the students are going to have years upon years showing their progression and all the different skills that they've gained in their time as a student, rather than just throwing that on paper. So what we'll be looking at in these next slides are going to be examples within these ePortfolios. But an ePortfolio is something that I really promote, and I really encourage people to use, because we live in a skills-based economy. And in a skills-based economy, it's all about those certificates. It's all about putting those examples on LinkedIn and having those hyperlinks. I mean, a lot of resumes, a lot of cover letters are no longer hard copy. They're submitted electronically. And for that person to be able to have the luxury of clicking on a link and learning more, but also for those students to increase tenfold their cover letter and their resume, is really powerful.
And so we have another example here, Professor.
Okay, yeah. So this
briefly.
example here, this is another student, and this student did a really good job of organizing what they learned through the semester in terms of the different labs as they went through. So there's 16 weeks in a semester, but obviously some of those weeks the students are continuing on with the same exercise and whatnot. In this case, what the student did is they did a really good job of putting this out into a tutorial mode. But what they're also demonstrating here is how they engaged in 3D mapping using the Skydio platform. And in this case, what they're showing is how they created an ortho mosaic. And this is the processing in Pix4D. So if CJ, if you could go up to the top, and maybe we can go to the Skydio 2 indoor scanning, or is that in a different one? And so in this case, what we have is we have the student showing how they engaged in inside three-dimensional mapping using Skydio. And what I'll say with Skydio is that when we first had a Skydio demo, I was a little, not iffy, but I was just kind of going, okay, Skydio, just another drone. I'm really happy that it's American manufactured. This is the reason why we're doing it. But when I was shown the 3D scan capability in terms of how you can go over a three-dimensional object and put down pillars and surround that object and say, this is what you want to fly. And then the platform uses AI, it uses that edge-based computing to figure out its own flight plan. That's what sold me. And then when I found out you could do this indoors, it really sold me. So in this case, we were inside doing this mapping because when we were there, it started raining. And so we were sitting there and we were waiting for the rain. I said, let's just go inside and do this. So we went inside and the students engaged in mapping out indoor environments using Skydio. And so in this case, what this student is doing in their ePortfolio is they're not only showing that they know how to do it, but they're showing that in terms of here's how you do it.
Yeah, the autonomous flying and autonomous inspection is pretty incredible when you first see it. I think we can all attest to that. So,
you know, that indoor scanning. The other day, I actually I used this portfolio in a sales call with the Department of Transportation, and the reason I did that was they did not believe that you could scan stuff inside. And the example that they want to do is you have in, more winter environments, right? They put salt and sand on the road in the wintertime. And they have all these big salt and sand piles inside these indoor semi-open warehouse environments. Well, if you fly a 3D scan indoors over that salt pile, You now have a point cloud where you can measure the volume and know exactly how much material there is so that they can monitor how much salt they're actually putting out, which is also important later down the road because now a lot of research is going into, well, we want to reduce our salt usage because that salt is now going into the ecosystem when the snow melts. And that salt is also affecting people's vehicles by causing rust, etc. So there's a lot more to do with, hey, like as a student, you learn one thing, and then in the real world, we're finding a multitude of different examples of where that's super valuable.
Oh, absolutely. Absolutely. I mean, it's really interesting that you brought that up because that was something that I was approached about a while ago. And I more or less had to say, well, I don't really have the technology to do an indoor environment, but you're absolutely right. I mean, volumetrics is huge. I mean, that's again, that's really how I got my name known in UAS was volumetrics in the mining industry, is in lowering overhead costs. And what we were demonstrating is that you could get within 0.01% of what the actual volume of these piles was.
Yeah. I mean, even this one here, right? We're talking about student work for 3D modeling indoors of a room.
Yes. Well, and in this case, this student, you know, what I love about this student's blog is they start out right away and they say, I'm going to be blunt about this before I'll be up front. I never even heard of the Skydio S2 Plus. So when I was assigned to do this, and so this gives you an idea of, this is a student that they were introduced to the Skydio. They did some of the online training components. They had the platforms in hand, and then we went to this facility and it was, okay, let's make an indoor 3D model. And these students, this was a first crack at it. This is something to where this was not multiple iterations of trial and error. What they did was they set their pillars and they decided that they were going to map this lectern, which is a part, if you can't recognize that, this is the Wright Forestry Center. And so that's a half of a log there for the podium, but they generated that 3D model. And it's a very good 3D model for a first crack. And this could definitely be refined. And that's one of the things that we all talked about this in terms of what facets of the digital transformation are here in terms of edge-based computing, AI, and whatnot. And then we talked about, you know, what does this compete with? And we were talking about how this can be a cheaper alternative to LiDAR and these indoor LiDAR scans, and what we could do if maybe, how could we refine this data collection a little bit more? How could we get in some of those voids? Why are some of the voids there? It was the lack of overlap of photos. Could we merge these two projects together? And so it turns into a huge discussion. And one of the great things about an ePortfolio is that we can bring these up in the classroom because they're publicly available. And, you know, the other thing I'll say with the ePortfolio and them doing this is that they're publicly accountable. And students don't like being accountable to other students. It's easy to blow me off and turn in a piece of junk. But when they turn in a piece of junk and then they have to go up in front of the classroom and they're all red in the face because they have a junk product, the other students, they give them shame. And so this is, you know, I'm just kind of off the cuff thinking that, but it's a really great thing to have this to where we can bring these up and we can share this material with others, such as the people on this webinar.
Yeah, absolutely. I just wanted to throw in one real world example of the indoor stuff that's really popular and I see all the time, and that's reconstruction of crime scenes indoor. So a lot of police departments are starting to use drone technology and photogrammetry to reconstruct crime scenes inside. Whereas previously these folks were using laser scanners, which are way more expensive and way more time consuming. You know, and another example that's really cool from an engineering perspective is monitoring the production of large assets being built inside a warehouse, like an airplane or an airplane engine. We have companies out there that fly Skydio indoor scan, and they make photogrammetry models, seeing how the progress is going for building a large piece of a machinery or equipment indoors. And that's really cool, right? Because now a student, that's something that they're doing in industry every day.
Yeah, I mean, in volumetrics from the reverse perspective of not a pile, but a hole, I had a trial attorney contact me and wanted three-dimensional models of a parking lot because of a lawsuit involving potholes. So stuff like that, the imagination, when you have the technology, the imagination can take this to a lot of different marketing applications. Okay, so what we have here is we have introduction to UAS for agriculture, but agriculture is something that this was one of the first markets for UAS. And one of the reasons why was, well, because it was when UAS was first out there, it was kind of Wild West and everything. So this was an example where it was rural and you didn't have to worry about, urban applications and everything. And the high temporal component, the ability for these things to fly low and slow. There was a lot to do with agriculture, but one of the things that was realized right away with UAS and agriculture is that it unless it was integrated with the other technology in terms of the inputs of the fertilizers and the seeds and those types of things, it really didn't have its niche. And now we see UAS in agriculture, but with things like Planet Labs and the ability to image the Earth every day, UAS it's not what the hype was brought to. But at the same time, one of the things this group of students did was they said this was a local farmer, and they were looking at using UAS in their operations. And one of the things that the students did was they said, okay, they want to be crop consultants when they get out of Purdue. And so one of the things that they did was they said, let's make something for this farmer that shows how you can use UAS at multiple tiers. And rather than getting into some of this crazy stuff like the multispectral sensor and NDVI indexes from using that near infrared band, or full color IR imagery, why don't we instead do something where we can show them how you can use drones from the most basic level of just basically doing crop scouting all the way up to using some of these more advanced platforms where you can do like post-processing correction GPS and putting multispectral sensors on these platforms. So they presented this farmer with kind of like an a la carte menu and saying, here's what we did at your farm, and here's how we used different types of UAS technology on your farm. And these are the different types of things that you can do with it, from that crawling to walking to running level. So that's just, I like this ePortfolio because the other thing about it is that you'll notice that it's not on a weblog. It's actually through what's called a story map from Esri. And so with story maps from Esri, you can do things like embed maps into it, and you can do swipe maps. There's all that you can do animations with maps. So here goes a swipe that they did. So that's an actual map that has coordinates. So yeah, we're good on that, but this was an example that the students provided there of showing how you can use UAS from a very basic level all the way up to a very advanced level.
And there's two more examples we want to get through. We have about 5 minutes, Professor. So
okay. We'll burn through this really fast. So
cool.
What we have here is we have students who again made another story map. And in this case, what these students did is they were approached by wildlife scientists, and the wildlife scientists wanted to engage in a deer count. And the traditional way of doing a deer count is where you walk transects and you look at deer scat piles. So deer poop, piles of deer poop, and you extrapolate how many deer are in an area based on how much deer poop you have. So what we did in this study is we compared those ground-based measurements with what the students were flowing, but the students are not wildlife ecologists. What the students are is they are UAS pilots. And so what they were instructed to do was to make a workflow for a landowner in terms of, okay, if I want to use a drone to do a count of cattle, if I want to do it of coyotes, if I want to do it of deer, how can I do it? And so they figure out you don't want to have overlapping flight lines because you don't want to overcount. But what they did is they showed in this study how you can calculate your field of view, how you can plan on a mission, and how you can do that flight without doing any type of an overcount. And so this same method is what we're going to be using on this DNR grant for doing this deer and coyote study. So these are just some really nice graphics that they have. And again, this webinar is recorded and everything, so people can feel free to look at any of this stuff. So we can go to the next slide, CJ.
Yeah. Yeah, and like Professor mentioned too, it is recorded, and we do have links to all these different e-portfolios, story maps, and what you can send out upon request. So just if anybody wants to see that, we're happy to provide it.
And this I'll be really quick on, but what I want to conclude with in terms of how you can be engaged in doing UAS work is that, as I said at the beginning, as we move forward, we're going to reach a point where we have to integrate drones into the airspace, and integrating drones into the airspace is going to involve GIS. And so in this case, this is a PhD student, and what they did is they took flight log data, and then they also took data from drone flights, and they looked at how they correspond and conflict. And they not only looked at it in the XY, but they also looked at that elevation, because what they're trying to figure out is, how can we tease out a potential given designated elevation within some of these more busy airspaces where we can have drones flying in conjunction with manned aircraft safely and effectively. So if anyone's interested in air traffic management, GIS, I highly encourage you to take a look at this, because this is just a very, very, very rudimentary, exploratory component of research that is still ongoing, but it has a lot, it's very exciting. It has a lot of potential. So this is what I teach in that graduate level course, more traditional GIS, but I just want to show that drones and GIS doesn't necessarily need to be just not imagery. It can also be used in terms of traffic management. So with that, I'll be quiet, and we'll probably delve for conclusions.
Yeah, that was great. Super informative. I know we had a couple questions come in. We only have about 2 minutes left. One of the questions, which on God, I saw you answered already. So somebody said, are you familiar with the Florida UAS drone rule? If so, does the 2+ meet those requirements? I know the X2 meets those all. And oh my God, yeah, you responded that currently not, right? The S2+ is not NDAA compliant. You're on mute.
Sorry, the S2+ is not NDA compliant. The X2 is NDA compliant, as well as our enterprise controller. But I also want that, particular individual to send us an email directly to see what type of organization they're part of, to make sure that we're giving them the right information based on the latest up-to-date regulation. And I think with that, this has been a great webinar, right? I appreciate everyone's time. And I really want to have a call to action that, if you have a drone program, reach out to Adorama Drones about Skydio. And if you don't have a drone program and you're in the educational space, or you feel that there's a department member at your university that does, reach out to learn more, because you're bringing in really important technology that's becoming one of the most critical changes in the technology landscape that's ever happened, with these flying robots that are doing a lot of good out there.
Yeah. No, well said. And like Angad mentioned, Adorama has expert pilots on staff, people that are familiar with all sorts of drone platforms, and we're happy to hop on a call and answer any questions you have, kind of walk through what you're thinking, talk about your needs, or a member of a bunch of different co-ops and contract vehicles too, to help make procurement easy. So if you have any questions, you can email me if you'd like, cjsmith@adorama.com, or drones@adorama.com. or head over to adorama.com/drones, fill out one of our forms on the site, and we'll follow up as soon as we can. So I want to, thanks again, everybody, for joining. I know we're right at the hour now. Thanks so much, Angad, and thank you a ton, Professor Hoopy. Super informative stuff. It's great to see all the work that you're doing with the students and some of the actual tangible deliverables that they're creating and kind of getting to go out into the workforce with. So I think it's just really impressive to see. And again, this is recorded. It'll be emailed out to everybody after the fact. And if anybody wants links to any of the story maps that we showed throughout the presentation, we can forward those to you all as well. So just reach out. Thanks again, guys. I'm Guy, Professor. Really appreciate it, and everybody have a great rest of your week.
Thank you.
Yes, thank you very much. And thank you everyone for attending.